if I can ask the speakers to
Right.
start sharing their slides, and I'll introduce you as you do that.
All right, great. Let's see.
Yeah, so next up, I think we're gonna have a tag team talk. Or
I'll be giving the talk.
Okay, perfect. Yeah, so just it'll be Robert Caldwell, who's a professor at Dartmouth University, especially in cosmology and in particular cosmic acceleration, among many other topics, and also one of the chairs of the cosmology working group. And he'll tell us all about that. So thank you very much, and please take it away.
Thanks, Will. Can you hear me fine?
Yeah, perfect.
Okay, great. So first of all, two things. One is a shout out to all my cosmology working group pals who are in the audience. Thanks for coming. And second, thanks to Shane for setting me up, because I really just have to swap astrophysics for cosmology in a lot of these things and describing the structure, how we work. Just go from kiloparsec to megaparsec or something like that, or gigaparsec. Okay, so I want to give an overview of the LISA Cosmology Working Group, and just really 4 points to hit on to review that, what we're about is exploring and promoting LISA science of cosmological interest, and define and share with you a little bit more about the role of the Cosmology Working Group, discuss some of the main activities, which are projects and workshops, research white paper, really similar to what Shane was describing, and then mention some of our plans for the immediate future. And I want to add that my co-chair is Germano Nardini. He's here somewhere. So if you ask me a question I can't answer, then maybe Germano will pipe in. All right, good to see you. Okay, so let's see. So the LISA science objectives. So you may know, originally proposed, LISA has 2 science objectives of cosmological bearing. The first is to probe the expansion rate of the universe, and the second is to understand stochastic backgrounds and their implications for the early universe, and in particular for TeV scale particle physics. So these are the bread and butter of the cosmology working group. And so a large portion of the work is obviously on standard sirens, developing them as a tool for cosmology, bright sirens with electromagnetic counterparts, dark sirens, and looking really beyond just cosmological parameter estimation. And then there's stochastic backgrounds. Many of the cosmology working group members are theorists, early universe theorists, and so stochastic backgrounds is our domain. That's one of the things that we explore, the theories of stochastic backgrounds, and then also looking at methods to extract science out of a detection or bounds on a stochastic background. Okay, but beyond the 2 originally proposed science objectives, there's obviously a lot more cosmology that one could extract from observations by LISA in the millihertz frequency band. And that's, our main activity is exploring and advancing that science. Let's see, I should add LISA in cosmology is rapidly accelerating. It's soon going to outpace the expansion of the universe, and it'll approach the metric length of phys rev d on the bookshelf pretty soon. So LISA cosmology, if you look it up on Inspire or whatever's your favorite database, it's been growing since 2015. Obviously, everyone's excited about gravitational waves, and in particular the last two years since 2019. And this is just parallel with the development of the general gravitational wave cosmology literature. So from within the LISA cosmology working group, and also I recognize that there are plenty of people outside the cosmology working group who are interested in gravitational wave cosmology and obviously how it applies to LISA and other proposed instruments. So this is a growing topic. So let's see, the role of the Cosmology Working Group. Membership, like Shane described, is through LISA Consortium. We have approximately 300 members, maybe 310 or so. Of those 300, I would say roughly 100 of them are active. At our workshops, we get, 50 to 70 to 90 people participating. We have on the order of 100 people participating in our research white paper, our main project right now. So that gives you a rough idea of the active size of the group. And the tasks of the Cosmology Working Group, we want to identify new science opportunities, because many of us are theorists, and that is our bread and butter, trying to look for new science opportunities, and then at the same time develop new methods of analysis to realize the potential of these opportunities. What we do, many Cosmology Working Group members use the shared benefit from the shared knowledge and experience from participating in the Cosmology Working Group for their own portfolio of research papers, the things that we do. But also within the group, we've had in the past working group projects where a group of people get together and work on a project to make more substantial these ideas and the goals, outlined by Lisa. The idea is, of course, to have an idea for a new science opportunity, develop that either on one's own or within the working group, and have that develop through projects until it gets mature enough and significant enough that it gets absorbed into or recognized by the consortium as being worthy of more technical analysis, and that's when it becomes a work package. So let's see. So let me just briefly mention our main activities. Workshops, we've had a really successful string of workshops over the years from 2015. We've had a number of projects that are helping guide the gravitational wave cosmology literature, and I'll mention our research white paper, which is now in progress. So what are these Cosmology Working Group meetings? They're more than a themed workshop. It's not just like going to, GR or a Marcel Grossman meeting or a AAS or something like that. It's more than a themed workshop. We have planned topics, and a lot of care goes into developing the agenda, guiding the discussions, so that it focuses on particular topics that the chairs and the members think are interesting. So here's a list of our meetings. The last two in Padua and Paris were both virtual. And if you're interested, those are the URLs if you want to look at what the agenda looked like and to get an idea. Just as the literature has taken off and exploded in the past few years, the attendance at the meetings and the size of the Cosmology Working Group has also grown. I don't have figures for the number of people in the Cosmology Working Group over the past 5 or 6 years, but Germano can check me on this. I understand that the attendance at the first few meetings was small. It may have been 20 to 30 people. And with Paris and Padua, okay, those were virtual, but we had 70 to 100 people at those last two meetings. So it's really grown. So here's some color here. This is the front page for the most recent workshop. And just to give you an idea of what goes on, we had, for the agenda, we had updates from the consortium, a talk from Alberto Sassana about the sensitivity curve, the talk by Stas about the data challenge. And then we had focused discussions on various topics. Some of them are organizational, and others are getting reports back on some of the ongoing or legacy projects that we we've had, like on primordial black holes, modified gravity, maximum likelihood map making, etc. And so this is a typical working group meeting, and in the past we've had them just about once a year, and sometimes a little more frequently. Here are some examples of some recent working group projects that have resulted in a paper. They span a variety of topics. A number of them have to do with stochastic backgrounds, sources of stochastic backgrounds, and also map making or detecting the shape of a stochastic background. So various aspects of standard gravitational wave cosmology. Okay, the third item that we're working on currently is this white paper. The Cosmology Working Group is tasked with producing a white paper periodically. The idea is to present the state of the art and to point out opportunities for science, which, as I mentioned, can eventually work its way up to objectives and priorities for the LISA mission. And here are some of the 100 or 90 or 80 active members on the white paper. Some of you in the audience may recognize your names. I put everyone here alphabetical order by your first name. So hopefully I haven't missed anyone, although I know I have. Anyway, the point is to show there are a lot of people involved with this project. Let's see, and then just sort of turning the corner to wrap up, this white paper is it's about 120, 130 pages, 100 authors, 1,000 references, similar to what Shane was describing. We have chapters on some of the bread and butter science, the standard sirens, and gravitational wave lensing, which is a new and growing topic in gravitational wave cosmology. And I thought for fun, this isn't really a science talk, but there was a figure in it that I think is just so cool, so I like to show it, that Miguel put together, showing the effect, wave effects on gravitational waveform for a lensed gravitational wave, hitting right at the Einstein radius or so. I think this is really cool. The red line showing the change to the waveform in Fourier space. Anyway, I think that's really cool. So you always learn something. Okay, so let's see. We have among the topics that are important to us are phase transitions, topological defects, as sources of stochastic gravitational wave background, and of course with phase transitions and strings, we have the possibility of connection to beyond standard model particle physics. So it brings in that other topic as well. Let's see, we in this research white paper that we're putting together, we also have chapters on pipeline tools that are at various stages of development for analyzing stochastic backgrounds and also looking at transient signals in the context of doing cosmology. Okay, so this white paper is currently in being edited. It's mostly written, just needs a little polishing here and there, and so it should be coming out pretty soon. And the last thing I want to say is, what are our future plans? Well, we've had a slight reorganization recently among the working groups, which helped us to delineate work packages from Cosmology Working Group projects. We have new additional co-chairs coming sometime soon, to start in August, similar to what Shane was describing. So they'll, beyond myself and Germana, we'll have 2 more uh, co-chairs. One of them, I believe, will be an early career scientist. And we are embarking on a new mode of operation where the activities are more focused on the activities of a theorist, smaller groups writing few author papers, but occasionally getting together to produce a larger document like the research white paper. And tentatively, we're thinking about having a workshop, a virtual workshop, probably in the fall. That'll be our next gathering. All right, and that's it. So thanks for your attention. And if you have any questions, I'll be happy to answer them.
Yes, thank you so much for that very nice overview. Yeah, well, people are starting to type up their questions. So let me take the chance to ask a question myself. So I was wondering if there are any sort of things that keep you up at night in terms of, oh, we really need to understand these cosmological sources better before LISA launches, or we really need expertise in this that we don't have now.
Well, I I don't think anything's keeping me up at night. However, I do recognize that there are huge uncertainties in our plans for cosmology with standard sirens, and that has to do with our lack of confidence or our lack of knowledge of the source populations. And that goes beyond the confines of the cosmology working group, but I think that's really important. I think something that that once kept me up, but I think we're on the right track, is finding the right cosmological question for LISA standard sirens to answer. We're potentially going to have a very interesting measures of the expansion history at a range of redshift that's inaccessible to a number of other experiments. What are the right questions to ask? Are you going to learn about dark energy? Are you going to learn about H naught from those high redshift measurements? Maybe, maybe not. So I think shifting attention to thinking of the right questions is helpful.
Great, thank you. So I've seen a number of questions have popped up. So Scott Ozer is asking, what defines the boundary between the cosmology group and the fundamental physics group, which we'll hear about in the next day or two?
That's a good question. we have a lot of overlap, and I think it's grown organically. The distinction. So we don't have a defined line between us, and there are people who belong to both and work on both. But for example, a number of issues having to do with dark matter belong to or are pursued much more actively in the fundamental physics working group, whereas the large-scale distribution of dark matter is more interested, more a topic of the cosmology working group. And we try. I don't know how great we are, but I don't think we've had any calamities. But we try to communicate with each other.
So another question is from Douglas Scott, who asks, so some of the goals you mentioned were somewhat speculative, but what's the most sure or guaranteed cosmological science from LISA?
Oh, well, for sure. Hey, Douglas. For sure, it's the standard sirens, and right, and one of the things that I'm most interested in and has been a growing topic is different ways of using dark sirens to make inferences about large-scale structure and fit it in indirectly into cosmology. So right, yeah. So the standard sirens is the sure bet.
Thanks. So Darren Haggard was asking, I'm wondering whether you think the participation of smaller groups or institutions has been facilitated by moving your workshops online?
I don't know, but it's definitely easier for me to attend. I'm in the US, and all the meetings have been in Europe. So yeah, it definitely, having it virtual, it makes it a lot easier to participate.
Yeah, so if anybody has any final questions, feel free to type those in the chat. Still have a couple minutes. Yeah, I was wondering if, I guess, sort of the more speculative sources, if there's any ones that you're sort of most excited about, stuff that is not a sure bet, but you think there's a might be some real possibility of seeing that you're most excited about, and as a theorist.
I'm excited about putting bounds on a stochastic background. Right. So, if you ask any longtime gravitational wave theorist what really drives them, I will bet that most of them will say, I want to detect a stochastic background. Okay, that's the ultimate. Okay, so it's got to be that, to find the irreducible hum of space-time. Where it comes from, there are so many different ideas. Even just detecting it would be fantastic. And Lisa, I think, represents the best chance for a spectrum that's not crazily tilted. Then the lower frequency you go to, the better shot you have. Just how detectors work. And so I think Lisa is the best chance for detecting or putting a substantive limit on a stochastic background.
Thanks. Yeah, that's definitely would be very exciting. Yeah, so I think if there, well, if anybody comes up with more questions, feel free to throw them up in Slack. But if not, thank you again for that very nice overview.